Yeah, yes, it is.
Yeah, and they don't know what's moving ever. They never know what's moving because you could go on the tree
Yeah,
and say the tree's moving. You go in the car, say the car is moving. You never know what's moving.
yes, we know in reference. It's a reference. You get it? They're talking about reference points. So we know we are going through the debris field at the same time every year.
No, they don't know that. They don't know if the
The,
debris
the,
field's going through
the,
us or
the,
we're going through it. They never know what's moving. You could be on the
no,
sun and say, you
that
could
is
get on
a
the
quant.
surface of the sun and say, oh, everything's
You're talking.
still and it's all moving around me. Or you could get on Earth or the moon or Pluto and
No,
do that same exact shit and say, I am still and everything's moving around me. They
no,
never know what's
Yeah, there's
moving.
a kinematic equivalence. That, in fact,
no.
saves
That's
the universe.
mainstream PhD level.
Right. You're talking about relationships to other objects, right? The
Okay, you don't
debris
understand this.
field.
So, kinematic
No,
The
you
equivalence
equivalent.
was
don't
invoked.
understand it. I am
It's
good.
the
You
equivalence
don't understand.
principle. It's the
It was
equivalence
invoked
principle.
to save your model. You do realize that because
No, the
everything
model.
appears to move around the Earth, and so they came up with the kinematic equivalence excuse. So if
Right.
you're denying relativity, then you can go in and make your own model, bro.
No, we're not denying relativity at all.
What is the basic principle of relative motion?
Basic principle of relative motion is to determine if you're moving or what you're observing is moving.
Thank you. Thanks for
Right.
playing.
Great. You're very welcome. Now,
Hey,
the
hey,
where the debris field is, it is at a certain place around the sun. The Earth approaches it every year.
Or we are in a certain place, and the debris field approaches us every year
No,
because it's in the same place. That
no,
if you're driving around a neighborhood, or if you're on, or if like a crowd of people are running around, then they would eventually come to you the same way as if you were going to the crowd of people. Also,
no.
you're also
Different.
begging the question with the heliocentric model
No.
because you're
The
assuming that
debris
it's a debris field that we approach.
the debris field is located in the same place around the sun. It's
hey,
also
bro,
moving. It is also moving, but it's not moving in our reference frame.
hey,
How do you know?
I got a good question. Like, just
It
a,
is orbiting. It is orbiting the sun on its own different reference frame, and it crosses our orbit. You
Great.
get
So
okay,
it?
begging
bro.
the question.
Right. It
Okay,
Begging the
bro.
crosses
question.
our orbit.
If I change the example,
Our orbits intersect. Do you understand?
okay, just
Yeah, just
imagine.
begging the question.
No,
You keep
there's no begging a question.
Hold on, man. It's
Orbital.
Yes,
just the guy's trying to get
There's,
because
in. Rob, it
how do you
sounds
there's
like
notice
you were
that
done a bunch of
debris?
times.
Yes, it's called orbital mechanics. We have laws and formulas wrapped around orbital mechanics for the Earth relative to the debris field.
Go ahead,
So we
next one.
know, so we know that we are
Oh, dude, I
orbiting the
thought you were
sun.
done again. Damn.
Sorry, we know that we're orbiting the sun at
We
60
can't know based
or
on that.
27,000 miles
Hold
per
on.
hour, and the debris field is doing the same thing, but
Hey,
in a different
when did you measure the orbit of the Earth around the sun? Can you give me a direct measurement? I've been looking for one.
Hold on. It's the next guy's trying to get at it. Just tempt mute Rob because he's obnoxious.
Okay, I have an example. Do you know what? Like, if I have orbit of ISS, so if someone is observing ISS and we know the trajectory and we can see, okay, there is something that is moving. So by that moment, can we say like the ISS is moving, or can we say, oh, the Earth is stationary? Oh no, the ISS is stationary and the Earth is moving. We can't say that. Do you know why? Because ISS have an individual motion that can be determined, and that is not following the other stuffs, right? But in the sky, everything is like having a pattern, like sun, moon, planets, stars. They have a certain pattern, so they have a model. But ISS is not like, it's a very different question. Like, sometimes people can't answer that. Like, just imagine, like, if I answer, if
Let
I
me
ask,
respond to this before you go on any longer, please. Is that cool? Or the ISS is in the same predicament Earth is in. Anything free falling, you never know what's moving. It's indistinguishable. It's the equivalence principle. You don't know if the ISS is still and everything's moving around it. They're in free fall, dude. You can't. That's what I'm saying. The PhD level guy, they're like, you can never know what's moving. Do you even ask what's actually moving? That's a silly question, according to
Yeah.
PhDs.
So next, I think next might be invoking things like retrograde and stuff like that. Is that what you're saying? Nexa?
If I talk about the sun, okay, so if we can say, okay, the sun is moving and the earth is still, and the planets are moving around the sun, and the stars have a certain, right, they are also moving. So we can create, then we can say, okay, the earth is not moving and these all things are moving. But by man-made objects like ISS and other stuff, we can just say, okay, the ISS is moving. We can't say like the ISS is still. Because there is no way to say that. How can someone say that?
Yeah. So, the geocentric
I
model.
agree with. Hold on, real quick. Let me just answer that. I agree with you. A man-made object, we would know if it's moving or not, 100%. Just like the car at the tree. The mainstream PhD levels, though, they don't think you can ever know what's moving. That's not like me. I think I agree with you. I know what's moving or not. You're on my side of this. You're not on the mainstream side though, where they say you can never know what's moving.
That's why I invoked references.
Yeah, so
Reference. Right.
retrograde can easily be explained by a geocentric model if the planets were just moving around the sun. Parallax also doesn't work for you either because you're just assuming what's moving. All the proofs of heliocentrism are basically just denying the kinematic equivalence that saves the heliocentric model. And with your debris field, once again, you're assuming what's moving. Just because something happens at a predictable time does not mean that you should just beg the question, assume that we are orbiting the sun, which is causing that. It could just be that is moving and it has a cycle. Your birthday, I can make several models maybe predicting your birthday, but that doesn't mean that because my model is true, it's just a cycle.
No. Wait, that's why I invoke reference. You guys are skirting around the obvious. There
Okay.
are
No, they
references.
use the
They
reference
are.
frames when they're telling me they can never know what's moving. They're invoking reference frames.
Okay,
They're saying
according
reference
to
frames are the reason why we can never tell what's moving because you could be in this reference frame or that reference frame, and either one's going to look like you're moving in different ones.
That's why.
They don't know.
That's
according to
why.
relativity, there is no absolute reference frame, so you can't invoke reference frame. Like we
Yes,
can't access it.
they are 100% absolute reference frame. If you look,
Great.
you use parallax.
Oh, write that down.
What you have done here, they're absolute reference frames. You are on Earth, it looks like the sun is moving. That is your reference frame. When you leave the Earth, you will see both reference frames. You will see the reference frame of the sun and you will see the reference frame of the Earth. That is how you have determined that the Earth
You
is
can't
what
see the reference frame of the sun from the Earth.
you
You can't.
cannot see it because you are the
How high
one
up
that
do you got to get? Okay,
you
how high up do you got to get to see the reference frame of the sun?
as long as you can see both Earth and the sun, you can determine that the Earth is what's moving.
The
And the
entire
Again,
Earth.
dude, I'm
the
telling
sun.
you right now, bro. They're You're going against PhDs, dude.
No, I'm not.
Yeah.
You are.
According to
Reference
wait.
frame.
According to Einstein, like you should maybe study relativity because you
Yeah, you're
obviously
going against
know
Einstein, all the
about it
PhDs.
because
You're going against.
Nope. I am
Einstein
100%
himself
on point
said
here.
you can never tell what's moving even from outside the solar system.
Y-
Yeah, dude, you're going
Yes.
against all of mainstream
No.
physics.
What you
Okay.
Yes,
in
yes,
order to
yeah.
see
Say it in your real voice again.
He knows better
in
than
order to
Einstein.
see
He's smarter
in
than
order
Einstein
to
when I
see the
disagree
Earth
with him.
turning on its axis, yes, you'll have to be a couple light years away. We don't care about that guy. We have other
Okay.
ways of doing that. We have
Hey,
interferometers
do
that
you
will
think
see
you
how
know
further the
know
Earth
better than
turning on its axis.
Einstein?
Sorry, say that again, sir.
Do you know better than Einstein?
No, No, I don't
Of
think I'm
course he
better than
does.
Einstein.
Oh yeah,
I don't
yes
think
you
I'm.
do, because you know better than Einstein, because he said that there is no absolute reference frame.
Einstein said there's no absolute reference frames.
And not
Yes.
only is he going against all of Einstein and the
Okay.
PhDs in
All right.
mainstream physics, he's going against all the globers that I've ever debated on anything like this.
What they were talking about reference frames. That's what they were trying to drive you toward.
Yeah, let me know when I can jump in.
Yeah, but
Go
there
ahead,
is
Now's
no
the
brother.
time.
absolute. There is no absolute reference frame according to relativity. So why are you invoking reference frame when there is no absolute reference frame?
Well, thank you for quantifying absolute. Thank you.
Yeah,
I'm
so it
going to
goes
go
back to
into
Newton's
everything I've been saying the entire time, and you just keep going back to, oh, that's why I'm invoking reference frame.
Absolute
Reference
is the
frame destroys
qualifier.
you.
Absolute is the qualifier. The sun is moving. The sun is moving. Do you understand? It is moving around the galaxy. That is a different reference frame. Absolute is the qualifier. Do you understand? Now, if you take out the word absolute, you are now localized. So in the localized sense, in your reference frame, you are moving around the sun. When it comes to absolutation of things, the galaxy is moving, the sun is moving, the earth is moving, the moon is moving, the stars are moving. So you have no absolute reference frame. You guys have to understand this. It's
Yeah,
time for you guys
so
to join the scientific community. Thank you.
May I please? May I please? Thank you. This goes right back to Newton's bucket. So the bucketeer, the guy in the bucket, when you spin the bucket and you see the vortex in the bucketeer makes the wrong prediction. And so when he's talking about a reference frame outside of that, an absolute frame, there is one, and it's called the lab frame. And to quote Professor or Dr. Bennett, it's the lab frame is unique and absolute. Dynamically unique and absolute, in that it can make the right prediction. All the way back to Newton's bucket. Just a guy in his bucket.
yeah, I think Einstein mechanics is different than Newton. I'm not sure what you're saying.
Yeah, Newton
So if you
had.
know Newton's bucket,
Oh, go ahead.
go ahead, Jeremy.
No, Newton had an absolute frame in that paradigm, but you guys have switched from that paradigm into the relativistic paradigm where there is no absolute reference frame. I mean, dude, you're going against everyone I've ever talked to about this that's on the globe side. My guys are the only ones who think there's an absolute reference frame.
There is no absolute reference frame.
Yeah, we know. We've been trying to tell you that. Okay, you agree
I
with us then.
know
Cool.
you are not. You're not understanding what we're saying. All things are moving in different reference frame. If you are standing somewhere, you are going to see motion. What you think is motion. Once you leave that object, you will be in a different reference frame, and you will see a different thing. What Einstein is saying is that all motion is relative. That's what
Thank
Einstein is
you.
trying to tell you.
That's why you can
Right.
never know what's moving. You can't know if the
Yes.
meteor stream's
But
moving into us or if we're moving into the meteor stream. You have no idea.
it's in respect to reference frame. Do you understand? So when you come off, when you're on the earth, it seems that the sun is moving. That is what he's saying. Because you are stuck on the planet. You can't, there is no, okay, you don't see the outside of the planet. There's no walls, there's no object around the planet that's changing. Everything is moving at 1,000 miles per hour. You're in that reference frame. You're locked in. You can't tell the difference. Now,
That's not true.
it
If you're
all,
at 45 degrees north, you're not moving nowhere near 1,000 miles an hour.
that's a different reference frame. Thank you. Thank you. Now
And
you're
that's the reason why you
now
can
you
never know what's
now
moving
you're
because
back.
you can just
That's
be
how
in different
spheres work.
reference frames.
That's
And
how
that's the
spheres
reason
work.
why you can, and
That's how
yeah, we
spheres
know.
work.
So
Stop,
how
dude.
did any of this prove that Earth is revolving around the sun?
That is how spheres work. So you're at the top
No.
of the sphere,
My God.
right? You see that? Your angular motion is a little bit different than your angular motion at the equator. different reference frames. Now, what the best
Yeah,
thing
but
for
you're
you
the
to
one who
do?
said you're the one who said we were moving at 1,000 miles an hour, and I had
Yes,
to correct
where
you
you
on that.
are at your latitude.
It's
At
weird
your
how
latitude.
this is an actual tactic people use in debates where they get shit wrong and then they just adopt your
No, you're not doing
position
anything wrong.
and act like they were
No,
right the whole time. He's done
absolutely
this.
not.
This
Ab-
is the second time he's done it within
Yeah.
hold on.
literally
So
like 2
I've
minutes.
gotten, I have
so
gotten
Star,
nothing wrong here.
can
The
you
issue
take
is
what
your
you said
understanding. Hold
and
on. Hold on. At your latitudes where you are right now, all of you, you're moving at average speed of almost 1,000 miles per hour.
Not
That is
true.
what I was talking about.
That's not
Yes,
true on the
it's true.
globe.
Yes, on the globe, yes, you are. You
No,
are
not
turning at roughly 1,000 miles per hour. Yes, you are.
that's
And
not
we have,
true on the globe.
yes, it's true because we have interferometers that have measured that. Thanks to Albert, Morrison,
You could be at
Michelson,
45
right?
degrees.
Th-
No,
Thanks
not
to,
true, dude. You
thanks
could be at 45
thanks
degrees and
to
doing like
Albert.
half that speed.
Thank you,
hey,
Albert Michelson.
that's not exclusive to
Right.
your model because we can easily explain it if you have a vortex and ether rotating around the Earth. If you have the
Hold on.
sky rotating around the Earth, Albert Einstein himself said that it would translate motion to the Earth, which would cause things like a pendulum to swing. So
Hold
we
on.
totally expect it. I would be shocked if there was
Welcome
no
to science.
measurement by the gyro.
You guys are summarizing the science. We know the details.
Do
What
you want?
Einstein
Let
said.
me. Do you want?
Yes.
Hey,
So
hey. Do you
let me
disagree with
let me
Einstein?
just finish it. Let me just finish this real quick. Yes, your speeding with your turning on the globe is different at different places. But at all the latitudes that you guys are right now, you're roughly 1,000 miles per hour. Roughly, you're off. Maybe you're 800. Maybe you're 950. Some of you know what I'm saying. That's where you are. Yeah, if you're at 45 degrees, yeah, it's probably half, right? I'm just giving an average. Now, when you get off of the ball and completely get off the ball, right? You will see that the earth is what's going around the sun. And you can measure that velocity. You can,
So
right?
tell me how you measured the orbit of the Earth around the sun.
Easy. So when say you're located on an object, let's say you're on Mars, for example, and you are observing the earth, you will see that the earth is in different positions in the sky, right?
Great. Thank you,
You
question.
can do,
Thank you,
hold
question.
on, easily. Distance divided by time. What is that?
So when did
Velocity.
you go to Mars?
Velocity,
When did
hold
you go
on.
to Mars?
Distance divided by your time is your velocity. Do you understand me? That's how you know the earth is moving. You get it?
No, no.
Right.
When did you go to Mars to do this?
When did what?
When did you go to Mars, or when did anyone else go to Mars and do this?
Hold on. I've never been to Siberia. Siberia doesn't exist. I'm sorry.
No, no.
I listen to other people.
Okay, here. Let me explain to you this. Okay, I'm not. You are claiming. You are making a positive claim that
You're claiming that Siberia
about
exists. I
Mars.
think Siberia
You
exists.
wait. You are making a positive claim about Mars. Substantiate that, otherwise it's completely invalid. You have the
Substantiate
burden
what?
of proof. I don't have to prove that it doesn't exist. You have to prove it.
Me,
And
me,
there's a
me,
difference.
me
Siberia,
meaning humanity. Me meaning humanity, or me meaning me. Wait a minute.
you
Oh, me.
substantiate it.
Okay. I've never been to Siberia. I can't substantiate it. I'm sorry. I have
Yeah,
to
if
want it.
you made a claim about Siberia and
Yes,
then I challenged it and you haven't been
many
there,
people.
then if I said I don't know if Siberia is a real place
Right.
and
Many
you
people tell me
wouldn't be able to
Siberia.
argue with me unless you had evidence that it existed. You can't say, I know that someone
I
killed
have
someone.
evidence.
Wait. You can say, I know that someone killed someone. And then you're like, how do you know? Oh, did you see him kill him? Oh, just because I didn't see him doesn't mean he didn't kill him. You need to prove that the person killed someone. You can't just say, I saw this is true, but then someone challenges it and you try to shift the burden over to them. Basic logics. Now, can you provide a direct measurement of Earth's orbit around the sun from the Earth?
Okay, so yes. So somebody, when I ask flat earthers, does Siberia exist? They say yes. I'm like, well, prove it. They're like, well, I can call people. There's 100,000 people that live there. I'm like, really? I've never met any of them. It's the same thing. You understand?
No, that's still flawed. So, if a flat earther invoke something and you decide to challenge that, what they invoked, they can't shift the burden over to you. As I said, if you claim that someone killed another person, say Bob killed Tom, you say, "Oh, I know Bob killed Tom," and then someone's like, "Did you see him?" And then you're like, "Oh, just because I didn't see him doesn't mean he didn't kill him." That's stupid.
Yes. Well, again, I asked flat. I did this. I said, does Siberia exist? And they say yes. That's a claim. I said, prove it. Have you been there? No. Okay. It doesn't exist.
No. Why are you jumping away from my analogy?
It's the same analogy.
Okay,
You
if you
invoke a
claim
claim.
that Siberia is hot, and then someone says, "How do you know it's hot? Have you been there?" And then you're like, "Just because I haven't been to it doesn't mean it's not hot." That's what you're saying. So now you can't. Why do you think you can make a claim that that something would happen on Mars when you haven't been there? What grounds are you making that claim from?
Humans have been there.
No humans have been to Mars. That's not even, according to you, to everyone who's ever existed. No human has set foot on Mars. It's only been rovers.
No, not physically. We've sent devices and instruments.
Yes, that's exactly what I was saying. Humans have not
Exactly.
been to Mars.
Right.
So,
Physically.
have you, or any other human testified that they've been to Mars?
Have you or any other human been to Siberia?
Yes.
Okay, can you prove it?
Hundreds of humans.
Right, exactly. See,
But I don't need to bother to prove it.
right.
If I'm invoking Siberia as a proof of something, and you challenge that and say,
I'm
"Well, how do
challenging
you
it.
know
I'm
Siberia?"
challenging it now.
Wait. Did I invoke Siberia
Yes, you
as
did.
proof of? Did I? Why don't you let me finish? Did I invoke Siberia as proof of anything?
Existence. Proof of its existence. I
I
asked you, does it
invoked
exist?
proof of its existence as proof of its existence? No, I did
Yes,
not.
I asked you if it existed. You said yes. That's a claim.
No. I don't deny Mars exists. I deny
Oh,
that
really?
people have gone there and that certain things would happen on Mars. Okay? If you say that
So this
Siberia is
is
hot,
positive.
okay.
All right.
Can you claim Siberia is hot? Are you allowed to claim that without substantiating it?
No, I'm just happy that you accept that Mars exists. So I'm happy with that.
Yeah, but that doesn't prove Earth is orbiting around the sun because you have not been there. Neither has anyone else.
Yes, we have been there
No.
with our instrument.
Robots have been there. You have not been involved
No,
with.
I don't have to. No. We just been through this. You have not been to Siberia.
Okay, yes, and you can rightfully say it does not exist if I'm invoking it as proof of something.
Okay. Well, sure. Is Siberia hot or cold? Which one?
I do not know.
You do not know.
Yes. I don't
Okay.
even know, I don't know much about Siberia, and I'm not going to make
Okay.
claims.
You're not going to make claims. Okay. Fine. So then, if you don't want to make a claim about Siberia, that is good. Now, I'm going to make a claim about Mars. I'm going to make a claim. I'm going to say humans have instruments on Mars.
Cool story, bro.
Okay, great. See, you see, I know exactly what you're doing. I know your game. Yes, we have instruments on Mars. Correctly.
And when did those instruments measure
we
the
have
orbit
the
of Earth around?
Ingenuity. We have all those rovers. China has one there now. Yes, they're all.
Have you seen the Mars rovers on Devon Island?
You mean
You can go to Devon
hold
Island
on.
on Google Maps, and you conveniently find Mars rovers on there.
You
And
mean
you can see, if you go look at pictures of Devon Island, you can find
hold on.
pictures that look just like they're on Mars, just a different
You mean
color.
the places that they're testing? They're testing the
Yes,
rovers.
and then pictures from Mars. You
Do
can
you
take pictures.
know?
Wait. You can take pictures that they took from Mars
Right,
and go to Devon Island, have
right.
pictures from there, and compare them. The only difference is the color.
No, you were fooled on that. That's a lie.
Okay, well then you have to show me how I'm wrong, because the
Yeah,
pictures look
you're wrong.
completely identical.
Yeah.
Oh, there
You're
you
not.
go. There's a squirrel on Mars, and there's a fly on
I'm
Mars.
gonna tell you. I'm gonna tell you that you're lying because you saw it on YouTube from an unverified source.
I saw it on YouTube about it.
Yeah, it's a verified source. Yes, unverified source. Those sources are not verified, so
You
falsified.
can do it yourself. You
And
can do it
basically,
yourself.
and
You can do it
basically,
yourself.
no, do okay. Let's go to Devon Island and see the actual rovers that are on Mars. Now, it is imperative that NASA tests their equipment before they send them off to Mars. So yes, there's a lot of test equipment on Mars, on Devon Island. Just like there's a lot of test equipment at different places where Boeing tests their aircraft. In California, there are places where they test their aircraft before they put them line up for passengers. So don't you think NASA would test the rovers, my friend?
Yeah. So why can't they just be changing the color? Because I
Uh,
can do that myself, and but-
Unverified source.
and then why can't they just be changing the color? And
Unverified. The reason why they went to Devon Island because
wait. So if I can go to Devon Island just without comparing them to Mars, I can go to Devon Island, take a picture,
yes.
remove the background. It's very easy to do,
Oh Lord, remove the back.
and I can add a different hue to it, and it will look just like Mars.
Wow.
Or
Look.
better yet, I can make a studio, or I can make a movie
Wow.
with plenty of those things easily. So you're telling me NASA, like just a few people? Let's just
Right.
say there's 2 people. They could easily do that. Then
Mhm.
when they send those rockets off, the data that they're connected to would simply, like the people who would be controlling the Mars rover.
Mhm.
I'm giving you the least amount of people involved. They
Okay.
could simply be controlling a rover on an island.
Really?
So can you rebut that?
Yes. Devon Island is a test site. It's a known test site that you and I can visit. If NASA was trying to lie to you, they would have not allowed us to go to Devon Island. You see that? Tourists go there to see their test sites all the time.
Yeah.
NASA invites people to come and see their test facilities.
Yeah.
So if they were lying
how
to
long would
you,
it
why
take
would
to
they allow
how
you
long
to
would it
go to
take
their test facilities?
how many hours of footage do we have from Mars?
I don't know exactly, but I'm sure
Okay,
thousands.
we don't have very much.
What?
We don't have very many
What?
hours of footage. We
Dude,
literally don't.
I watch entire documentaries on the Ingenuity, and those are official footages from the Mars surface, and it is ours, right?
I didn't ask for a documentary. I
Right?
asked how many hours of footage. So
Footage
in
upon footage.
wait,
Hold on, let's go to NASA's
in
website.
less than a
NASA's
week, you
website.
could get all that from Devon Island.
No, you can't get it from Devon Island. Sorry,
Why?
because you and I can go there.
No, why didn't they? Why couldn't they have gotten it
If
beforehand?
you and I, if you and I have access to a facility, then that's a problem for the liars. The liars.
Yeah.
Nobody's
So,
following you. You can go to Devon Island right now.
no. Yeah. How big is Devon Island?
It's very small.
Yeah. Are people there 24/7 every single area of Devon Island?
Well, it's not a very hospitable place, so I wouldn't go there. Hence the reason why they use it. Because Mars is not a very hospitable place.
So you just said that people don't visit there much.
No, they don't. No, because
Yeah.
why?
So
But
I don't
you
have a
can.
problem. Wait, I don't have a problem if they don't. visit it. There you go.
Okay.
They would have plenty of time. They could just do it when people weren't there, or they could have done it before, in times where people aren't there. So, like, they would have plenty of time to do it. And also, it doesn't have to be Devon Island. It can be another island. But basically, it's impossible for them to fake it.
Well, yeah, you're going to have to prove that, and
I have to prove it's fake.
Yeah, you're going to have to. Yes, that's you. You're going to have to prove that.
Okay, so I can show you an AI generated picture of a unicorn,
Oh,
and then you have to prove it's fake. Wait, I have to show you an AI generated picture of a unicorn. You have to prove it's fake. Okay.
Okay.
Yeah, you have to prove it's fake.
Sure.
You can't just say, "Oh, unicorns don't exist." You have to prove things are fake. Otherwise, they are real.
Sure. Can I go where unicorns are?
No, you have to. Yeah, can you go where Mars is?
I can't go where unicorns are. Oh.
Can you go to Mars? Can you go to Mars?
No, I can go to Devon Island. We're talking about Devon Island.
No. I'm talking about how they could fake. They can easily fake pictures of Mars and videos of Mars.
Easily.
So, and I can easily. It would be very easy.
Oh, really? That's what
you need to catch up on technology.
Well, you're gonna have to prove that it is easily fake. Like if you go to NASA's website right now, they of the Perseverance footage. Go ahead, take a picture of somewhere and fake that.
Yeah, I can generate an AI video or something.
Yeah, go ahead. You mean AI? You mean so you want to use AI?
What? You can use AI. You can use AI. First of all, I'm just saying how easy it is to fake it.
I'm just saying Perseverance went up way before AI existed. I'm just saying.
Well, yeah, how do you know that AI didn't exist before that? Do you know that they don't release it right when they discover something?
Sure.
Do you think that they discover it, release it a minute after they discover it?
Okay.
So why couldn't they have been keeping
Okay, so unfortunate for you. Well, you're going to have to prove that.
No, I don't, because it's well known. It's well known that they can.
You're going to have to prove that NASA had their hands on AI before AI was released. You're going to have to. I mean, they had neural networks back in the 90s. They did have neural networks. The first neural network was launched at the Chile Observatory's BLT. To look at large data. They did have neural net, but that was just a data reader. It wasn't a graphical generator. It was just a data reader.
Yeah.
So yes, so they had that.
So yeah, that's what the mainstream story says. But obviously, if NASA's lying to you, you think they would? If NASA's lying to you, you think they would? If NASA's lying to you, do you think they would reveal everything to you?
Yes, they would. They would.
Wow.
The reason why, because monies are involved, budgets, taxpayers' money.
So if I was lying to you that I killed, if a murderer was lying to you that I killed someone, do you think he'd reveal all the details of the case that could lead to someone? Well,
if he needs funding to commit his murder, he's going to have to report to somebody.
No. I said, would he reveal? Would he have to reveal everything, or would he want to reveal everything?
It's best for him because he's using outside sources of money. Yes.
No. If I kill someone,
especially if his money is being cut. If his money is being cut every year, he's going to have to come clean because poor NASA's budget has been cut every year from 5% of the federal budget to less than a fraction of 1% of the federal budget now.
They receive plenty of money. They get millions per year.
Yeah, I know, but it's less than a percent. It's a fraction. It's less than a percent of the federal budget. It was 5% in 1969 of the federal budget. 5%. If you adjust it for inflation, that 5% would be equal to $35 billion today. Do you know what NASA's budget is today? $35 billion. So poor NASA
Yeah,
has not received
that's a
any
cool.
more money. They have not received any more money. They have to be things are going up in price. They have to be using the same amount of money that they were given back then to afford equipment. That is why the staff is leaving NASA and gone to work for SpaceX and Virgin Atlantic because they're not getting paid. And here's the last thing. In the next budget coming out, 50% of NASA's budget is going to be cut again. So these poor liars, wow, somebody's on to them. I mean,
Yeah, that's a cool non sequitur to the actual point.
no, I'm just saying. I'm just saying,
How's this
if the
relevant?
United States government was making big googly bucks off of NASA, why are they cutting the budgets? Come on now.
Okay, that's non sequitur. So the point was, if I kill someone, do you think I would reveal all the details of what happened if I thought it could expose me?
You were caught. You're in court. You better make a plea deal.
No, if I'm not caught and not in court, if I'm just a witness at a trial because I got then someone is asking me all questions. If they ask me like, was I nearby something, or like where was I on this night, or did I have a knife on me? Why do you think I would reveal all those things if it would lead to me being exposed?
Yeah, no, you're in Devon Island, remember? So you're being exposed. I can go there right now and take pictures of NASA's activity.
No. So you said that they don't have all the technology back then. I'm saying they could have had it. They just didn't reveal it. You're saying they would have had to reveal it. That's like stupid.
Yes, they have to really reveal it because their budget is being cut every year. Poor things.
Why didn't they have to reveal it?
Okay, all right. They are going to be
You
cost
think they
overrun.
need billions? You think that they need billions of dollars to fake their things?
Yes, they do. Helium costs a lot of money.
Yeah. Helium is not part of their fakery.
No, I'm just saying. These things, CGI generators, they need a lot of money. People are
CGI
not
does
cheap.
not. CGI generator would not cost a lot of money.
Yeah, it does. For the
No.
scale in which you are talking about.
They should work
Yes,
with
they do.
look at some AI apps. See
AI, big
how
man.
talk
AI did
talk
not
to
exist
people
in the
who
80s.
made the apps and
When did the
ask
first
them how.
clearance go?
Talk to people who made those apps and ask them how much it costs for them to make it.
Yeah, well, you're going to have to prove that.
Prove what?
You're going to have to prove that it's all CGI. You can't prove that.
Oh yeah, we have shown that most of their pictures are CGI.
No, you cannot. It's impossible. I've seen
Yeah. Do
nothing.
you want
Everything
me
that.
to drop
Sure,
a bunch
go
of
ahead.
videos
Drop some
exposing
stuff.
them?
Go ahead, drop some stuff. I've seen every single thing that a flat earth has shown me. It proves nothing, right?
Yeah. What about gravity pockets on the ISS?
Oh, you mean when they're on the test, when they're on the vomit comet? Yes,
No.
yes. They
The
were on the
ISS.
vomit. Yes, they were on the parabola plane for testing. That's where that picture came from. I went and I found
Not a
the
picture, a video.
original
The video
video.
on the ISS.
I went and found the original video. They were on the parabola aircraft when they hit those gravity pockets. They were on the
No, the
parabola aircraft.
ISS.
No, not ISS. No. They were on the aircraft. The person who made the video is a liar. He's a liar. And you believe him. Those gravity pockets, they were on the aircraft. Go look it up. Do the search yourself.
Not that gravity pocket.
When they're on the parabola aircraft and the aircraft completed its role and then they all kind of like just shifted to the
Yeah, I'm
left
not talking about that one.
okay. There's two
Talking
of them.
about on the
There's four of them.
ISS where they dropped some divorce papers.
They dropped some divorce papers.
Yeah, they were signing a divorce paper. Have you seen it? And then they drop it and it falls to the ground like on Earth.
Oh, somebody was divorcing. What was it? Butch Wilmore was divorcing Sonny.
No, I don't think it was that person.
Okay. Yeah, let me sign my divorce.
I found a complication. It has it in it.
Okay. Sorry, brother. You have been lied to.
No, you haven't lied to, actually.
No, not
By
me.
now.
It's all verifiable. There are people who are there. They can come and they can tell you. You can speak to astronauts
He's a
yourself.
believer, man.
1,000, almost 1,000 people have been to space and have seen the Earth. The Earth is. We don't have a model.
Okay, well,
The globe is not a
1,000
model.
people have been
The
on the
globe is not a
ISS.
model. The globe is an
1,000 people have
empirically
been on the
observed fact.
ISS.
Huh? Say it again.
1,000 people.
A thousand.
Where do you define space? What's the altitude
A
of where you start
thousand.
call it
Almost
space?
1,000 people have been to space. Yes, sir.
No, what is space? Like,
Space.
what is the altitude that you're calling space?
Okay, space is not the ground.
Have
Yes.
1,000 people been on the ISS?
I need to look up that number, but I know that almost 1,000 people have been to space. So I suspect the
Yeah, the fact that
ISS
you can't
alone.
define space means that you're just
I
repeating it
think
from
I
someone.
think the ISS alone. That's a nice fun fact to learn. I'm going to look that up. But I'm sure maybe 500 people have been on the ISS. I would say.
Yeah. So how does that prove anything?
Are you
They've
just
been to the ISS.
are you just making up numbers, dude? The number is 290. Why are you
Well, okay.
saying
I'm sorry.
500? Are you just winging it here, or what's the deal, dude?
Just said
I
it.
mean,
You
I
heard
can
what
be
I said?
gracious to him for that. It's
No, I
okay.
just yeah.
Science make mistakes like that. But
Yeah. I said I did not look up that number, but I was just guessing maybe 500. But hey, I'm off by two. I'm off by 300. Sorry, 200. Yeah.
yeah.
I
So
apologize.
To
so why
say he's
can't they all?
winging it is being generous.
Yeah. Well. I was. Yeah. I've probably been generous. Yeah, you can say that.
Well, don't let your zealotry get the best of you to where you start making up numbers.
No, he asked me, and I said I don't know, but if I was to take a guess, I would say 500. Those were my exact words, and it would be a fun fact to look up.
Yeah. So most of the people who have gone to quote unquote space only went up to like 60 miles. Okay. So you're
60 miles.
1,000 people. 800 of them aren't going up to space. They're going up to like 60 miles at the most. And like if you see Dude Perfect goes to space, Katy Perry goes to space, all those things, they were only
Yeah.
at they weren't even at 60 miles. I don't believe, and they wouldn't be been able to see the curvature of the Earth according to Neil deGrasse Tyson. And you can even look at a diagram and looking at altitude.
Again, Neil deGrasse Tyson was holding a spear in his hand when he was talking about the Baumgarten thing. You guys need to pay attention to that. If the Earth
Yeah,
was flat, why would he be holding a ball? Right?
called a
He would
hostile witness, bro. Look it up.
he would have said no. He would have just stood there, stayed away from the ball, and said, "All right, he's only a millimeter above the surface." I don't.
When did I invoke it as him saying that the Earth is flat? I'm saying, according to your religion, the globe religion,
Oh no, flat Earth is
you wouldn't
religion.
be able.
Don't project.
Okay, don't
Don't
pick
project
on
on
it.
us.
Okay, according to your
Don't project.
model,
Don't project on us.
according to
We
your
don't have a model.
model, you wouldn't be able to see the curvature even from 60 miles.
Yeah, we don't have a model. The Earth is an empirically observed spherical object. It's no longer a model. Since 1941, with the V2 rockets, it is a empirically observed fact that we are on a globe. It is not, you are the ones who have a model.
Yeah.
We, we, we have
Do you
hundreds of
agree with?
thousands, we have millions of pictures of the Earth curvature. Millions.
Yeah. So, do you agree with Neil deGrasse Tyson, or do you disagree?
What statement?
That you wouldn't be able to see the curvature even from 60 miles.
He was talking about the grand curve of the Earth. That's what he's talking about.
No,
He's not
I'm talking
talking
about.
about.
I'm not talking about the Felix Baumgartner. I'm talking about other times where he was talking about the astronauts who went up to 60 miles, and he said it was 62 miles actually, and he
Right,
said that they wouldn't be able to see the curvature from that height at all. So do you
Really?
disagree with him? I guess
He would.
you know
Okay,
better.
okay, okay. Hold on. Again, he's talking about the grand globe. He's not talking
No.
about 3-4 degrees of drop and 5 degrees of drop. He's not talking about that.
Okay. Once again, I'm not talking about Felix Baumgartner. I'm talking about the one where they went up to 62 miles. Astronauts, not Felix Baumgartner going up in a balloon where he's a skydiver. Not that.
Oh, are you talking about? So he was talking about the what you call it, the the space tourism when they go up to the Kármán line and just like 65 miles up and they come back.
62.
No, they go up 65 miles.
Okay, yeah, 65 actually. That's right. So yeah, thanks for
Right,
making my point
right,
stronger.
right. Yeah.
Thanks for making my point stronger.
So you're saying that Neil deGrasse Tyson says they can't see curvature.
Yeah, he literally said that.
They okay. Again, if he said that, he would be talking about the grand curve. You can see
There wasn't
curvature.
even a grand curve in that video. It was very small.
Yes, it is very small. Yes.
And that can easily be explained, first of all, by the circle of vision, the fact that you have a limit to your vision, and it's in a circle, kind of like you're looking out of a hula hoop. I can't. Hula hoop, yeah.
Oh, hold on. Did doctor
If
tell
you
you
have
that?
a circle of vision around you, like if you can see 3 miles ahead of you, 3 miles to your side, you draw it all around you. So stretch out a string of like 3 inches away from you, and then go in a circle all around it. It creates a circle. Now, if you draw that circle, then get in the middle of the circle, view the sides of where you would see. It looks like a curve, a small curve that would be, which is what we would expect. Now, if we didn't see it, then I'd be like, "What? Why is it like that?" So yeah, but they saw a very small curve. So your point is invalid about it being
No,
just the big hump. He said you wouldn't be able to see curvature from that height.
you will not be able to see the grand curve, but you can see a slight drop in curvature. Yes, you can.
Yeah. So thanks for you disagree with Neil deGrasse Tyson. Now go and make your own globe
No, no,
model.
no. I don't. No, he's talking about being able to see the the curve in a distinct way. That's what he's referencing.
So once again, they didn't even see a big curve.
Again,
You're really desperate right now.
no, dude, you can see curvature at 62 miles if you have a clear view of that horizon. Yes, you can. 100%. But it's very slight.
Okay, so go and make your own globe model.
What?
Because
We have
you
a
disagree
radius.
with Einstein,
We
you
have a
disagree with
4,000
Neil deGrasse
mile.
Tyson.
We have a 4,000 mile radius. You should be able to see the curvature starting at around 35, 37,000 feet. I myself have seen it at 40,000 feet. I saw it.
Do you think you'd see the curvature at 35,000 feet?
Yes. Based on the curvature calculation, it
Wow.
with a 60-degree field
According to the
view.
calculation, the
Yes.
Earth would be smaller than 6 miles if you could see the curvature at 35,000 feet.
It depends on how much curve you're talking about. Are you
Yeah,
talking how much?
a small amount, small degree of curve.
Oh, really? How small? I
Yeah.
mean, what is this? It sounds arbitrary. Again, due to the
The
radius
curvature
value.
that I have seen from an airplane window, which you should also know that an airplane window is curved,
Oh,
which
so
because when you're up that high, you need curvature of a window to help distribute pressure
why
evenly.
they hold on
And
why
so when you look through that, you can actually see. I've seen from the ground the lines on the runway. They look a bit curved.
hold on
Second,
why
you have your circle of vision.
oh the runway didn't look curved to me, but when I got up 4,000 feet, I saw a curve.
Bruh. You probably didn't look close enough. Second, I keep telling you, the circle of vision.
Circle of vision. Wait, hold on. Did
I
they,
already explained it to you.
did a biologist tell you this circle of vision? I mean, can we give me some papers on that? That everything looks curvy with your eyeballs. I mean, what's going on? I mean, are you talking about exovision, like your external vision? Yeah. I mean, you can see to the side. Like women are better at that than us. You know, they can see to the side more than us.
You're lost, man.
No, I'm just saying. This is
Do you agree
external
that if you're looking, if you're inside a hula hoop and you look at the edges of the hula hoop, it will look curved?
If you look at the inside of the hula hoop, it will
If you're
look curved.
inside a hula hoop and you look at the edges in front of you, will it be
Yeah.
curved? Okay, thanks for playing.
I mean, if you don't have any interference, yes, you can see that curvature. Yeah.
Yeah.
Okay.
So that's not exclusive to either model. And second,
No, no, no,
if
no.
you
Hold
did see
on.
curvature,
What?
if you did see curvature for
Hold on.
35,000 feet, it's way too small.
Your model has curve.
It has curved because of your curved vision, which is what we would expect in your model too.
Your model is curved because of your vision. A flat Earth is curved because of your eyes.
No, only slightly, just a very slight curve, which is what you see at 35,000 feet. It's very, very small, and you wouldn't be able to tell the difference between Earth curve and that curve.
Hold on. Okay, so
So
it's your
you
eyes.
do agree that we
So
see
flat
in a
Earth.
circle? You do agree that we see equal distance around us?
Mm.
So if I look to the right, I see 3 miles ahead of me, say, and if I look in front of me, it's 3 miles too, right?
Well, it depends.
Yeah, in a condition where like there's no other variables, you could see equal distance all around you, right?
It depends.
On what?
Are you at sea level?
No.
Are you at ocean?
If you're at a high enough altitude where there wouldn't be any trees or anything to interfere.
Well, okay. Remember. A sphere has circles everywhere.
That's non sequitur. So
Yeah, but it has circles everywhere. Yeah. So if you're standing on the side, it's still a circle. You're standing on the top, it's still a circle. If you angle 45 degrees, you're looking at a circle. If you angle 10 degrees, you're at a circle. There's a circle out in front of you. There's circles everywhere on a sphere.
no,
Yeah, you know that, right?
you're off, man. So think about
Well,
if you
just let me
place
know.
a man or place a nail in the ground, okay?
Right,
Then you have a string. It's stretched 3 inches ahead of you.
right.
And at the
Exactly.
end of that string is a pen. So that string represents how far you can see. Now you're going to draw all around, basically based on the limits of what your string can stretch to. It would make a circle around you, okay? That would be how far you can see.
Okay.
And if you make everything else black, because you can't see except for inside the circle, then you have a tiny camera in that circle. Then guess what you would see? Curvature.
You
Small
you
bit,
cannot
like what we
you
see
can
in reality.
but you cannot determine that curvature 3 miles away. You cannot. You know that, right? You're a 6 foot observer. You cannot see that circle in front of you. You cannot.
You can see the circle. It's in all directions in front of you.
No, you're just turning around. You went. I'm saying you're not going to be. You cannot see that circle wrap around you. You cannot determine. All you're doing is looking point to point. You know what I'm saying? If you look directly out in front of you, You're not
Yeah, so
determining the
let's
circle
do
around
directly
you.
in front of you. Let's do directly in front of you.
Right.
So draw your string out, have it straight in front of you. Move it to the right like a few inches, and then move it to the left a few inches. What do you
Right.
call that? A curve.
Yeah,
Arch.
it's a curve, but I'm just saying
Yeah.
your eyes are not discerning that curve.
Yeah, your eyes wouldn't be able to tell the difference between real curve and curvature of the Earth.
It's too, well, we know this. I mean, your eyes is not adequate enough. And the fact and the reason why you know that the Earth is curving is because of that horizon line in the first place.
No.
There's no need for a horizon line on a flat plane. I mean, like, really? The Earth is flat. I should be able to see out into perpetuity. It should
Okay,
just look
do you think
blurry.
there wouldn't be a horizon on the flat Earth?
No, only the ends. Why do you have a horizon in the middle?
Yeah.
Why?
So would it be all sky or all ground that we see?
Well, you would just see what you would see is convergence of the sky and the ground would be converging. The sky would be converging over your head, going all the way out to like,
Will we
and then
see
it
all
gets
sky or all ground?
and then it would look like a big, like it would have kind of a square look over your head and a square look on the ground. We don't get that. We don't get that. We get
That's
a
because that's not
curvy.
what you would see.
We get a
Okay,
curvy
first of all, do you deny that? Do you think we have a medium on the Earth? Is there air?
but no. You have no.
Let me
Wait.
No.
No, no,
You
no.
through this. This
What
is
I'm
very
saying to you,
basic.
no. You can't borrow the medium. No, there is
Yes, you
no
can.
need. No, there is no need for that line to be out there on a flat plane.
Yeah.
There's no
So
need. There's no need for
yeah.
a
So
horizon. I mean, on a clear day, on a hot day, that line is there. I mean, like, what's going
do
on?
railroad tracks converge?
Well, yes, they do.
Do streetlights appear to drop down and converge?
Okay, yes.
Everything appears to converge, and it converges at the place we call the horizon, which is also where your eye level is.
Dude,
So
if the lines beside, what
if
are
you
you
have the
talking about?
sky,
Bruh,
if you have the sky
if the
dropping
lines are
down,
smaller, dude, if the lines are smaller and closer together, they converge way before the 3 miles. So please, don't give me that nonsense. Right?
what?
Yes. If you have lines, dude, if the lines are closer together, they will
No,
converge
it's not
way
lines.
before the 3 mile point.
It's the entire land and the entire sky that's going to converge.
No, listen to me. The railroad tracks are converging way before the street lights. The street lights are wider, they're taller, so they are converging further out. The railroad tracks are converged way before that. I mean, like 1 mile out. 1 mile out, they converge. The street light will converge 2.5 miles out. You get it?
Okay.
So it's not a convergence. It's not a convergence. That
So
horizon is a
if things
that
converge,
horizon is a
if things
three
converge,
mile
you
for
have
a
the
6 foot.
entire.
It's a 3 mile for a 6 foot observer. 3.2 roughly for a
It
six
also
foot
depends on
observer.
the size of the objects.
What?
But listen, so if you have the entire ground and the entire sky going towards the horizon,
Right.
it will converge at the horizon. And guess what? Guess what?
Where's that?
The horizon fluctuates. So there goes your argument.
It fluctuates.
Yes, the horizon moves. I can see it myself. The horizon is not always in the same location. Your model itself says that.
Yeah, because of refraction.
Yeah. So great, shift the goalposts. So if the horizon's not a physical place, if
Of course,
the
it's a
horizon
physical
is
place.
moving, how do we
What is
know
it?
that?
No, dude. Something is there for it to be moved by refraction. You get it? You get it?
What?
Something is there to be moved by refraction. If
Yeah.
nothing was there, refraction wouldn't move it.
Yeah. So if we never see the actual curve of the Earth, how do we know it's there?
Well, that's a different. The horizon is how we know that the Earth is curving. The horizon, right? You get it? The horizon. Horizon.
Yeah.
There's no need for a horizon on a flat plate. It's flat. You should be able to you put on the binoculars and see to the end of that flat plane or a telescope.
If you can draw what you would see, then props to you. But
No,
yeah.
no, no,
So
no. If you draw
in a game, why can't you
right,
see all the way to the infinity? In a game where you have like a giant landscape, things converge. Everything appears to converge. Also, we have the reason we wouldn't see to the end of the flat Earth is because we have a medium on the Earth. So over a distance, air, it will build up. Just like if
yeah,
you're looking through water. If you're looking through water at a certain distance, it will be
so
thin, it'll get thicker and thicker and thicker until you can't see through it. Do you agree with that?
you need a medium to create your horizon.
No.
Yeah,
I'm saying
because there's none on a
no.
flat Earth. But we don't, dude. The medium is still 3 miles out there.
Yeah,
It's
you
still,
also need a medium to create your horizon because you guys have to claim
no, no, no,
refraction every
no. We
time
need
your horizon moves.
the medium. The medium is moving that horizon for us, but there's something to move. There's
Yeah,
something to
so
move. You need a medium to create it in the first place. Yeah, like
yeah.
you see what I'm saying?
No,
It's
we
like if I
don't.
put
No,
a
we don't.
wall, if I put a wall in the middle of a table, I have a horizon. You see that?
Okay,
So
I have to get
so
going, but you just need to answer this question. Like maybe
right.
Jeremy can talk to you. If there was no horizon on a flat Earth, would it be all sky or all ground? Thank you.
Be all sky or all ground. If there's no horizon, there is no horizon on a flat plane. You will zoom all the way out to the end. If you have a very bright object at the end of your flat plateau, you will see it. That does not happen on Earth. On Earth, you can put up the brightest object on the other side of the Earth. You will not see that thing because it's on the other side. For you, I should be able to zoom and see the sun. You know what I'm saying? You should be able to zoom and the sun is a very bright object. It's not dimming. It's bright. It's still bright. Morning till night. It's just bright. So you should be able to zoom to it. We can't in reality because it's obscured by the dirt. That's just a fact.